What's up YouTube, this is TuProfeYouTube here. Now we're going to talk about frequency distribution tables. So what it means is that inside a table that we're going to draw further on, we have to fit all the data we're given in an orderly manner, so it'll make some sense for some kind of study, some statistic study. So this is the case of a guy who is sitting on a terminal and he is asking 26 persons how far from their destination they are. And they are traveling to Tokyo, to New York, to Los Angeles, to Frankfurt, to Hong Kong, etc., etc. And they give them lots of numbers. So this means 5,944 miles from where he is standing, if he is going to, I don't know, Auckland or whatever, and that's the distance to their destination. So the first thing we need to do is to find how many classes do we have to draw in our table. I know the teacher, your teacher, probably it's going to give you this number, but sometimes this is not an accurate number. So I'll teach you right here how to find this accurate number, the right number to draw your classes in the distribution table. So what we're gonna follow the Sturge's rule. I'm sorry. And Sturge's law says that the number of classes is equals to 1 plus 3.3 log of the number of data. In this case, we have 26 values. So what you need to do is to make this calculation. The number is 5.66 that you're going to round up to 6, of course, because you're not going to have 5.66 intervals or 5.66 classes, right? So with this in mind, we're going to find the range of the data. That means that we have to take the highest number of all, and we're going to have to subtract the smallest number of all. This is because we need to fit all the data inside the table. So the range is equals to the higher number minus the lowest number, and that is 8,656, as you can see here in red, minus 329. That's the range. So that's 8,327. And this, with this, we need to find the width of every class. So the width of a class, or the interval width, is gonna it's gonna be found by taking the range and divided by k, which is the number of intervals, right? So 8,327 divided by 6, it'll give you okay, sorry about this, 1,387.83, okay? And we're going to round it to 1,388. With this in mind, let's draw. Now we need to fill this up. So we start with the smallest number, 329. 329. And remember that the width of the class or the interval is 1,388. So that means that the number, the upper level of this range, it's going to be 329 plus 1,388, 1717. Okay, now since this is the width of the interval, we only need to add 1,388 to this value and place it here, 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 and that's going to be the higher, the upper level of every class. That means that 1,717 plus 1,388, that will give you 3,105 plus 13,288, that's 4,493 plus 5,881 plus, the next number is 5,881 plus 1,388. That is 7,269 plus 57. 1, 2, 3, 4, 5, 6. So this is a total. There you go. Now, for the other number, the numbers that I'm drawing, that I'm writing here in blue, of course, this is not going to start from 1,717. That's going to start from the next number. So that means that this number is 1,718. So we add just one unit to the first number, to the last number of the past class. So with this in mind, this is a 5 or this is a 3? 17 plus. This is 5. Okay, so this is 3,106. This is 4,494. 5,082. 882. This is 7,270. And that's it. Okay? And we verify if this is the right answer, if this is the right result, just by saying, well, okay, we start with the smallest number and we end up with a very close number to the last one, to the higher number. Now, we need to find the class century. That means that we have to add both numbers in each class and divide it by 2. For the first class, we're going to add 329 to 1,717 and divided by 2, that's going to give us 1,023. And since they are separated by 1,388, we can take this number and add 1,388 and place all the numbers here, like this. That's 2,411 plus 7. $7,963, and the last one. Okay, that's the last one, and there you go. Right? There is no point on adding this up because this is the class century. Okay. Now we're going to find how many numbers from the list fit inside this range, and we're going to place the result here. We're going to do the same in all the classes. Okay? So this is the quantity of numbers from the list that fit inside each of the ranges or each of the classes. 9, 6, 0, 7, 2, and 2. And I have this technique just to, don't get mixed up scratching and doing stuff. This is the first class. So I placed a number, 1, inside all the numbers that are inside this first class. And then for the following number, I take into account this one, you know, the upper level of the class. And I try to find all numbers that are not marked, but that are less than 3,105. So I mark them up, and so on and so forth. Now for the relative frequency, which is a percentage, we're going to have to divide the absolute frequency by the total of data. That means that this value here is 9 divided by 26. This one is 6 divided by 26. Obviously this is going to be 0. And this is going to be 7 divided by 26. 2 divided by 26. 2 divided by 26. And that, each one of them multiplied by 100. So the results are going to look like this. And these are the results. Now, we need to find the cumulative absolute frequency. That means that we have to place the first number here, which is going to be 9, and then further additions of the absolute frequency of the next class. That means 9 plus 6, that's 15, plus 0, that's 15, plus 7, that's 22, plus 2, that's 24, and this is 26 finally. And we do the same for the last one, which is the cumulative relative frequency. That means that we place this first number here, 34.62%, and we add the next value and place it here. That means 57.7. And so on and so forth, and this is 0, so that means this is the same number. And then we add 26.28, that will give us 84.62, and 92, 31%, and finally we are going to get 100%. Okay, finally we have this table, and it is all complete, and it's very, you can extract a lot of information out of it. Now, we need to find those measures that will give us the important information that we're looking for. So, those are the mean, the median, and the mode. Let's start with the mean, I'm sorry. So, the mean is, what we traditionally do is, we have to add up all the numbers and divide it by, in this case, 26. But we're not going to do this. What we're going to do is, we're going to multiply the class entry times the relative frequency. And we add them up, and we find the mean. What I mean by this is 1023 times 34.62%, which is 0.3462 in decimals, right? 462 plus 2,411 times 0.2308 plus 3,799, and that is equals to 3,424.93, and we're going to round it to 3,425. Okay, let's place it here. Now we need to find the median. The median is the data or the number which is located exactly in the middle of all the list. So the equation is the inferior limit of the class that contains the mean. I mean by this, if we have 26 numbers, the mean has got to be on the number 13. And that is if we stay here in the second class? Yes, because we got 9 plus 6, that's 15, so that means that the median is in this class, between 1,718 and 3,105. So the lower limit of this is 1,718. This is the number here. Now, we need to add this to the width of the class, which is A, and divided by 2, minus the cumulative frequency of the mean, which is before the cumulative frequency of the class that contains the median, divided by the frequency of the median. That means this is what we need to find. 1718 plus 1,388, right? Which is A. 26 divided by 2 minus the frequency, the cumulative frequency of the class which is before the class that contains the mean. In this case, this is the number. It coincides that is the same number that was before, but do not get confused. It's this one, because what if we had the mean, which is what if this class contains the median, I'm sorry. You'll have to take 15. Okay? So this is 9 divided by the frequency of the class that contains the median, which is 6, right? And the result is 2,643.3, which we're going to round to 2,643. Okay? So I'll place it there. Now we need to find the mode. The mode is the number that repeats the most in a list, right? And the formula of the mode, okay. It is very easy if numbers were repeated, but in this case, you have no repetition, right? There is no numbers that repeat in themselves very much, right? Actually, there is no number that repeats in this list. So we need to use this formula. The mode is equals to the lower end of the class that contains the mode plus A. That's the frequency of the mode minus the frequency of the class before the mode divided by this same stuff times minus the frequency that is exactly after the mode, the class that contains the mode. And which of the classes, which is the class that contains the mode? Well, that's very simple. That's just the class that contains the higher number in a frequency, in an absolute frequency. So that means that the first class, it's gonna be the one who's gonna have the mode, right? And before that, there is 0. Okay, because it's the first one. And if we by any chance found that this is the class that contains the mode, the frequency before the class that contains the mode, that's 9, right? Okay, but this is not the case here. So the lower limit of the class is 329, the class that contains the mode, plus the width of the class times, so this one is the frequency of the mode, which is 9 minus 0, because there is no class before, and we're going to have the same here, But here, we're going to find 9 minus 6. Because it's the frequency of the class after the class in which we are going to find the mode. So this is the result. The result will give us 791.666666, and we round it to 792. And this is it. So thank you all for watching. Don't forget to drop a like, and I'm sorry about my English. I'm a little tired. I'll see you next time. Bye bye.